Hello and welcome to EE233. I'm your instructor, Gregory Myers. In this video, we're going to take a look at how to parse a file, particularly how to parse a file that has integer values in it. They will, of course, be stored as characters in this particular example. And we'll talk a little bit about what that means. This video is part of a larger series of videos focusing on file input and output, known as our files demo. It assumes that you have watched the introductory video of the files demo series, as well as having completed much of your fundamentals demo, including those videos that focus on the vectors and arrays in C and how to access elements in an array, as well as the for and while loops. So to begin with, what you want to do is make sure and obtain a copy of your parse_file_01 snip, as well as our input file. And so before we take a look at any of our code, what we want to do is quickly try to understand the problem that we're going to be tackling in this particular example. So you don't have to have this specific text file. What you do need to have, though, is a text file with exactly 100 rows in it. Now you'll see that that is going to be kind of an arbitrary distinction, and in a later video we'll show how to get around that limitation. But there will be exactly 100 rows, and you notice that the values in this file range from 1 to 10. The idea is that we would like to be able to build a function that will open this text file, read in all of the data, and convert it to integer values, count the number of each occurrence, and then output to another file, essentially a summary. Now that summary we would want to look like a 10-row and 2-column table. And for this particular example, we are going to choose to use the .csv file format, or comma-separated values, where the first column will simply be the value, and the second value, or the second column rather, will be the number of instances of that value. So let's go ahead and get started. The first thing that we want to do is we want to note here that we have some constants that we want to bring over. We'll put those in our files driver. We'll put that immediately following our preprocessor directives for the includes. Now we have some defines here. Once again, you'll see in later videos that some of these constants here won't in fact actually be required. We're just going to keep these first few examples fairly straightforward. In addition, we want to go ahead and bring over our function prototype, add that to our list, as well as bring over the function implementation and any corresponding comments. Now, the idea here is that we want to be able to open our text file and be able to read in all of the data into this input raw array or vector. And therein lies our limitation, because we have to decide up front exactly how many rows we want to allocate to this particular vector. In the future, we may not want to do that, or we may have another way of going about doing that. Once we have simply read in all of the data into our input raw array, what we will do then is to iterate through all of the values in that input raw array and simply try to identify then where they go in the output counted array and how many instances of each. Now, normally what we would do is have two choices. We could either pre-initialize this array, which is what we've done here. In other words, we've assigned then the values for the first column as being the numbers 1 through 10, You'll notice this nested curly brace approach that I'm using here essentially assigns the value of 1 and 0 to what we would otherwise think of as the first row, with 1 going in the first row, first column, and 0 being the number of instances going in the first row, second column, all the way through to the 10th row, the 10th row, of course, having the value of 10 for the first column and 0 for the second column. So in both cases here, for both the input raw and for the output counted, I have used a one-step approach of declaring and initializing the variable. Now, I do this intentionally for this example to show you that there are some examples in which we would want to initialize and declare all in one step. But you would agree that if your array got much larger than this simple example here, that initializing it in one step like this would become rather onerous, to say the least, or just to say, put it another way, is it would be a little bit of a pain to do so. So what we want to do now is we're going to go ahead and close our snips file. And we want to take a look at our files driver. Now, before we go any further here, I'm going to go ahead and build it just to make sure that you have a working executable. And then what I want to do now is I want to locate where the executable is, and I want to take that input underscore 01.txt and I want to put it in the same directory. So what I'd like for you to do now is take just a second and go to your file system, and I want you to grab a copy of your input underscore 01.txt, and I simply want you to go find your files demo, go into the distribution folder, in the debug folder in the MinGW directory, and simply go ahead and paste that file in there before we forget. Now, at this point, we can start working on our function. So we can simply start off by navigating, going to the declaration, going down and taking a look at the function we've copied over. And if you recall from our first example with file input and output, we want to use a file pointer. In this case, I have named them input and output. Those variable names are just for convenience. You could name them anything you wanted to, and you may also decide to be a little more specific. But in this case, what I want to do is I want to take my input file pointer and I want to use it to open up my input underscore 01.txt using fopen. So we'll simply say input is equal to fopen, and we want to specify our input underscore 01.txt. In this case, we are going to hard code our file name, and in later videos, we will look at how we can use a variable file name to be able to open up any text file or any CSV file that we might be interested in looking at. The second parameter then is going to indicate that we want to open this file for reading. And so I'm just going to put a little note here, open it for reading. And if you've watched the earlier video, you know that we want to always remember to go ahead and close the file, or at least write the code that would close the file and then decide later where that code goes. You can sort of think of this as a reminder to successfully or to appropriately close the file, and just simply go ahead and type this code before you forget. Now, the next thing that we want to do whenever we open a file, but before we attempt to start reading from it, is we simply want to check to see whether or not we were able to get a file pointer. For example, if in fact our input underscore 01.txt does not exist, then you couldn't get a open file pointer. You couldn't get a valid file pointer, in which case then the input would be equal to null, and we can't really go any further at that point. So the very first thing that we want to do is simply check to see if our input is not equal to null. And if it's not equal to null, we want to do something. And if it is equal to null, well, we have a problem. And that problem we would want to communicate back to the user. And in this case, most likely thing to do would simply be to use a printf and say error failed to open. And in this case, we'll go ahead and specify input underscore o1.txt. Now, if we were successful at getting a non-null input file pointer, then what we would want to do is we'd want to make sure that we eventually close that file. Not immediately, because we still need to do something with it. But once again, we just simply want to put that code somewhere that we don't forget that we need to do it. Now, at this point, we have an open file and we are ready to start reading from it. But we need to know when to stop reading from a file. And in general, files will have what is going to be referred to as a end of file. So that once you hit the end of file using fscanf, you will in fact return no more values, and then you can close the file. In this case, we have two conditions that we will need to check. The first one being whether or not we have reached the end of file, but also if we have collected 100 values, because we are limited in our input raw array to the first 100 rows. So in this case, what we want to do is we want to start off by initializing some of our temporary variables. So in this case, what we want to do is we want to initialize our current row equal to 0. And we're also going to go ahead and initialize our chunk count equal to 0. Now, the chunk we're actually going to use to read the information out of the file, so I'm not going to worry yet about initializing that. But going back to what we said were the conditions for which to read from the file. Essentially what we want to do is continue to read from the file while not end of file and while our chunk count is less than 100 or less than the number of input rows. And so if you notice the way that I worded that, I'm essentially setting us up for a while loop. So what we want to do now is we want to take a second to pause the video and take a look to see how our fscanf function works. And I've provided you a link for that. Specifically, we want to take a look at what the return value will be for fscanf. And if you notice here, it's going to be an integer. And so the idea here is that we want to use our fscanf to capture not only the value from the file based on the data type. So in this case, it's going to be integers. So we'll be using a format spec for %d. But what we also want to do is make sure that we have not, in fact, reached the end of file. And so to do that, then, let's go ahead and set up our compound condition. I'm going to make some notes here. We want to read the file. And specifically, while not end of file, as well as while we have not read more than 100 values. And so hopefully at this point you can sort of get an idea of what our compound statement or compound condition for our while loop should look like. So we'll start off with while and then a double set of parentheses, since we know that we're going to have two conditions here. We're going to use our fscanf. And our fscanf is going to allow for us to look at our input file or accept an input file as a file pointer. And then we want to capture a integer, so we know that it's going to be %d, and then we want to store that integer at the address of the chunk. Now notice, just like with just like with scanf, we use the ampersand in front of the variable to indicate the address of the variable. We do the same thing with our fscanf. And so what we want to do is we want to continue this while this is not equal to end of file. Now, before we go any further, we want to take just a second and figure out, where does this special constant come from? And if you notice, it's actually in your standard io.h. And you'll see that essentially what happens is your fscanf will return -1 when it hits the end of file. But we will simply refer to that as EOF, or end of file. But remember, we said that that was only one of our two conditions. The other condition was that our chunk count did not exceed 100 values, or in this case, our input_rows constant. So in this case, it doesn't really matter necessarily which one of the two conditions you check first, but you do want to check both of them. So what we're going to do here is have our while loop start by checking the chunk count is in fact less than our input rows. And our fscanf does not in fact return EOF. At this point then, what you can do, let's make sure real quick, I think we've got some mismatched parentheses here. Let's sneak another one in here. There we go. So at this point then, what you want to do is you simply want to store the current chunk in our input raw. And to do that, we can simply say input_raw square brackets chunk count is going to be equal to whatever that particular chunk happens to be. So essentially, the first time this while loop runs, it's going to use fscanf to grab the value of 9. It's going to store it at the address of the chunk, and then we're going to retrieve it from the chunk and simply put it into our input raw vector. At this point then, what we would like to do is simply print out the output value of our chunk. In other words, we want to print out the value that was captured from the file. And what would be nice to also do is to print out essentially the chunk count, or the index, or the zero-based, if we were thinking of the file as being the 0th line, the line number by which the value was found. So you can either do this based on the index or on the line number, it doesn't really matter. But basically what we'd like to do is communicate some information back to the user. So in this case, I'm going to go ahead and increment my chunk count. So chunk count ++, and we will simply use a printf, and we will specify that at line %d was the value %d, followed by a new line. In this case, the first value is going to get the chunk count variable, and the second value is just going to simply be the chunk. And hopefully at this point you can see what I was referring to when I said that you could have the printf earlier, essentially before incrementing the chunk count, and that would just give you the index in the input raw variable. At this point, we should probably go ahead and build our project and go ahead and set up our switches so that we can start running this example as early as possible. One of the benefits of putting your printf in immediately following your fscanf is that you can just quickly see whether you have successfully read the contents out of the file. So we're going to add another else if here, string compare I. our argv square brackets 1. And what we want to do is we want to check to see if the user wants to run our parse file 01. And if they do, simply call it. And then likewise, we want to take just a second to update our help. In this case, we're going to have a parse file version, a parse file underscore 01. And it's just going to count the number of integers, each integer. All right, so once again, let's go ahead and build it. Let's see here, we have a problem. Let's see if we can figure out what we did wrong here. Accidentally put in a period instead of a comma. Let's try that again. And once again, we want to cd over to our files demo. And into our MinGW directory, and you'll see that there is my files demo.exe. I'm actually going to take a second to delete one of the files here, the earlier version. I've renamed that executable. So I'm going to go ahead and delete it. That way we only have the files that we're interested in this case, our files underscore demo.exe, and there is our input underscore 01.txt. Let's go ahead and run our files demo.exe, passing our parse file 01 switch. And you'll see that we get a lot of noise on the command line, but useful noise, in that you'll see we are simply looping through using a while loop until we hit either end of file or 100 integers. And we are simply printing out the value that comes out of a specific line. So in other words, line 1 is 9, line 2 is 10, and so on. So if you've not yet been able to get this portion working, go ahead and pause the video and make sure that you can get to this point. Once again, this little trick here of simply reading in all of the values and immediately printing them out is always a good start when it comes to dealing with file input and output. Now, let's actually do something with this information. So we've read the contents of the file. We've now stored it in this input raw array. What we'd like to do now is we'd like to put it into the output counted array. But this example, we're actually going to leverage a little trick. If you'll notice, I intentionally gave you values from 1 to 10. And if you recall, when we were talking about arrays and vectors in C, C is zero-based indexing. So if you were to close your eyes for just a second and think of this array as a 2-column table with the first column being the value and the second column being the count of each value, the first row would have the value 1 in it in the first column. The index of that first row would be 0. So you have a relationship now between the value stored at that location and the index of that location. So likewise, the value 2 will actually be stored in index 1 or row index 1. The value 3 will be row index 2, all the way up to value of 10 stored in row index 9. This means that you can describe the relationship between the value in the index simply being the index is equal to the value minus 1. we're actually going to use that to our advantage in this example. And this is a very specific example. It was very intentional for our first example to see how we can do this. So what we'll do is after we've closed the file, we can start working on counting the values. So in this case, we can work on counting values. Before we do that, let's just take just a second to appreciate the fact that we've closed the file now before we do any other processing. Once again, this is a decision that will vary based on the type of project that you are working on, but in general, it's a good idea to close the file as soon after you are done reading it as possible. That way, in case you have another portion of your executable or another executable needs to access it, you don't leave it open longer than is absolutely necessary. Now, when it comes to counting the values, we essentially want to go back through and loop through all of the values in our input raw table and then compare them to the values in the first column of our output counted by that relationship of value minus 1. If we have a match, we essentially increment the second column. So the first thing that we want to do is build a for loop. And in this case, what we'll do is we'll leverage that current row variable that we have. And we're going to start off with the current row equal to 0. And what we want to do now is we want to continue looping through the input raw using the current row as an index all the way up to, but not including the chunk count value. So in other words, if we have read in 100 rows, we want to stop at index equal to 99 or row 99 because once again, C is 0 based. And then of course, we simply increment our current row by 1, you are doing current row plus plus. Now, the idea here is you want to remember relationship between the value in the input raw and the row in the output counted that it belongs in. And to do that, what we're going to do is we're going to start off by saying output counted. And to specify the row, we're actually going to use a nested set of square brackets. And specifically what we're going to do is we're going to use the value in our input raw vector at that specific row. So in other words, our current row. And remember, I keep emphasizing the relationship between that value and the index in our output counted as being -1. So there's value -1. This gets us the correct row. And what we want to do is we want to take a look at the value in that second column, or index 1 for our second index. And what we want to do is we want to take the current value and we simply want to add 1 to it. Now, in this particular example, it's going to be a little bit long. I want to use the verbose syntax here so that you can really appreciate it. But essentially what we will do here is we will take the current value. So in other words, we're going to replicate everything that we just did. Input raw, square brackets, current row, and the relationship between the value and the index being -1. And we want to take the value that's in that second column and we simply add 1 to it. So essentially what we're doing in this really, really long line of code is we are simply incrementing the second column. And I'm going to move this up so that you can keep it a little bit better on one screen. I'm going to increment the value in the second column. And believe it or not, because of that nice little relationship between the value and the index of that value, we are actually done with our counting scheme. At this point, then, we are ready to print out the values. So once again, what we want to do is we want to open a file. This time, however, we want to open our output file, and we want to open it for writing. So I'm going to say output is equal to fopen. And for my output file, I'm simply going to use a similar name to my input. So I'm going to call this one output underscore 01. But to emphasize a different file format, I'm going to specify .csv. And then I'm going to open this one for writing. So quick note here, open the CSV file or comma separated value file for writing. Likewise, what you want to do is always make sure that you can actually successfully open the file. So in other words, if for some reason you're attempting to write somewhere that you do not have permissions, you're going to get a null file pointer. You want to go ahead and check to see that your output is not equal to null. This is not likely to be an error that you're going to encounter unless, for instance, you've opened your CSV file in Excel, in which case it will be prevented from writing to. And then under the else, in other words, if our output is in fact equal to null, we want to warn the user. And this will simply be a printf, error, failed to open. And in this case, we are going to hard code the name of the file, output underscore 01.csv. Now, if we don't have a null output file pointer, we need to do something. So we want to write to it. And before you forget, just like with opening a file for reading, when we open a file for writing, we always want to remember to go ahead and write the code that will close the file, in this case our fclose output, and we can move it around as we see fit, but go ahead and put it there to start with. At this point then, we essentially want to loop through all of the values in the output counted array, in this case using a for loop, and we want to print out the 2 values in each row. So we'll start off, we'll once again reuse our current row variable. We'll start off at 0. We can then leverage one of our earlier constants. If you recall, we actually had 3 constants. We can leverage our output rows constant, or we can simply hard code the value of 10 in here. So while our current row is less than our output rows, and then current row plus plus. And at this point then, what we can do is have both a printf and an fprintf to demonstrate that we have been able to successfully parse or count our values. So we'll start off with our printf because that's the one we're most familiar with. And we'll have a %d with a comma and a second %d followed by a new line with that first placeholder simply getting the value of that first column of our output counted array. So in other words, it'll be output counted square brackets, current row, and then square brackets 0. That's the first column. For the second placeholder, it's going to be output counted, square brackets, current row. And then for the second index, it's going to be index 1. At this point, you can probably guess that our fprintf is not going to look tremendously different, with the only significant difference being that you need to specify your output file pointer. At this point, you could probably just go ahead and copy the remaining part of our printf statement. At this point, we should be done. You can go ahead and build it. Once again, we have green. That seems like a positive sign. And remember that since we already tested our switches, we know that we can successfully call this function. So at this point, the only thing we need to do is to rerun our executable with the appropriate switch. And you'll see that in addition to reading in each one of the lines, which is now essentially just noise to us, you have an additional output that indicates that there are 9 ones, 11 twos, 10 threes, and so on. And in this particular case, there are 15 tens. But that's not the most exciting part. The more exciting part of this is if you type in dir, you'll see that there is now an additional file, one that we can, in fact, drag and drop into NetBeans. And you'll see that the same thing that was on the console is now also stored in our CSV file. So once again, hopefully you found this video useful. We're going to continue with this series of file input and output known as our files demo. In future videos, we're going to focus on different data types as well as more advanced sorting algorithms and counting algorithms. This one was pretty straightforward. As a matter of fact, it simply leveraged a little trick here. Some of the other ones are not going to be as straightforward. But hopefully you found this video useful. And as always, don't hesitate to email me with any questions or comments. And thank you for watching.